Thanks for that introduction, and thanks for all coming out tonight. It's great to see you all here and hopefully wanting to understand a bit more about the issues. I work in academia, but in the research realm of academia. So I've been looking at plastics and plastic pollution over the last 15 to 20 years actually, and seen just the growing rates of plastic in our environment. Now, obviously we're here to talk about synthetic turf fields, and we've all heard the problems with different aspects of their health, environment, but also the benefits of them as well. Most fields are what are called 3G fields, so third generation fields, requiring some infill. So most around the state and around the country are still these older models, but they are moving into a 4G realm where there's less infill or no infill. But if we have a cross-section look through what a field looks like, basically it's plastic on plastic on plastic if you really want to talk about it. Obviously there's the blades, we all know is plastic. Then most of the infill has been rubber crumb, which is shredded tyres, but most of the tyres these days are a synthetic blend with natural rubber, so they're considered a plastic. And while it was seen to be a great avenue to dispose of end-of-use tyres, we're finding they're leaving the field and causing problems, and there's a whole lot of issues around the toxicity of that, which I'll show you in a minute. There's a polyurethane backing and then a rubber shock pad as well. So, you've got all these layers which, when it comes time to recycling, you've got to kind of separate all those. And while it is possible, there's a lot of plastics being used. And while I'm looking at microplastics, we're seeing this leaving the field as well. So, next slide, please. I'll talk about rubber crumb. Firstly, so rubber crumb, as I said, most of it's called styrene butadiene rubber. So like polystyrene, so it's made from the same polymer. But there's a whole range of other chemicals in that rubber crumb. So you think about the tyre itself, whatever was put in to make the tyre is still there in the crumb. So there's a lot of metals, particularly zinc, lead, cadmium, copper, example. There's fillers like carbon black, which we know is a carcinogen. There's volatile organic compounds that go up. Volatile just means they're going to go into the air and cause potential harm by us breathing them. And then a whole range of other things that are added as antioxidants. So there's to make the tyres last longer, they add chemicals in there. And so the 6-ppd is an interesting one because there's been studies overseas showing that the breakdown products of that chemical causes harm to Atlantic salmon. So it's also toxic. So there's a range of chemicals apart from, obviously the base polymer, which is that synthetic rubber. So we just got to keep that in mind. Okay, next slide, please. So we ran some toxicity tests with that rubber to see, what effects it is having in our waterways. So, as I said, where there's data from overseas showing that there's effects in salmon, we did some tests on some aquatic invertebrates. So we've got 3 species there, those little pictures you can't probably make out too much. The one on the left's a little water flea, it's called. It's a Cladoceran. So it's in our freshwater system, so it's a freshwater critter. The other 2 are actually larvae. So one's the mussel larvae and the other one's a sea urchin larvae, which are both marine. So we use these because they're sensitive to change in the environment. They're kind of sensitive to chemicals and changes happening in the environment. So we use them. They're actually more sensitive than fish to those changes. What we did some what's called leach trials, and we put rubber crumb in the bottle, leached it for about 18 hours, and then exposed these critters either for 42 or 72 hours, so 2 or 3 days to see what was happening. And the bars down the bottom really show the response. So when they're high bars, it basically means there's no response, and on the left is 0. And when we first did the tests, we put 100% of the leachate there, and it killed everything within hours, all those 3 species. We had to dilute it down, and then what you're seeing in the bars is basically we're seeing effects down to 3%, or depending on the species, around that level. So you had to dilute it down until there was only 3% of that leachate mixed with water before we got no effects occurring, all right? So in other words, it's telling us it's highly toxic. And so we measure that by EC50s, or you might have heard of things like LC50s or LD50s. That is just a measure that tells us what percentage is harming 50% of the population. It's a standard reporting measure. So for this leachate, we found between, let's say, 1 to 3% of the leachate was harmful to 50% of that. And they use that for regulation and for deriving water quality guidelines. So in other words, we're finding small amounts can be toxic. And when we looked at the chemistry of that leachate, what was the products in that leachate, as I said, heavy metals were high, particularly zinc was through the roof. The 6-ppd, which is an antioxidant that was affecting the salmon in the US, we also found was elevated, and a few other chemicals. Now, this was an unfunded study, and we haven't actually got money to go further, but it's at least showing us some initial concerns about the leachate, and this is of the rubber crumb. Okay, so this is why we're pushing to get at least the rubber crumb removed from our synthetic sports fields. We've also looked at around sports fields in Sydney, different sports fields, and measured what was coming off the fields to try and quantify that in some way. We took core samples of the soil at different distances away from the field, and when it's close to the field, you can see that number of 24,000 bits of, in this case, rubber crumb, right up against the field. As you go away, we're finding it out to 8 metres away from the field, but at lower levels. So higher, it kind of makes sense. The higher loads are right next to the field, and then it drops off. In some fields, they've got measures to capture that, and that's great. And so they put baskets in their drains. So if anyone's been to some of the fields, there's some drain systems that capture that water runoff from the field if they don't have an internal system. And we looked at what was in those drains. There were some baskets put out. And so measuring kind of monthly loads that these baskets are capturing, as you can see, let's say about 160 pieces of rubber and between 23 and 80,000 pieces of grass are being captured per month in each basket. That's one average of one basket per month. The variation just means if it's wet or dry. And interestingly, the big range with the synthetic grass, that the higher number is after rainfall. So the grass is more mobile and moves through into the drains more readily. The crumb being a heavier, it kind of sits and didn't change too much whether it was rain or not. So anyway, lots of pieces come off is really what that's saying, but by having measures in place around the field, and there is, as we've heard, some guidelines now for synthetic sports fields, and there is an Australian standard for these fields, it will trap or capture most of that material, probably 90% or so, is captured if they have the right techniques. Not all fields do, some fields do, and I know Cromer's an example of one that has some good mitigation measures in place. But what we found, even when there is baskets, and that last line there shows that it still bypasses. As you're probably well aware, it gets walked off, so it gets stuck in the player's shoes or whatever, and they get walked off. And so we found by sampling a creek downstream of these fields, we were still finding it in the creeks, both the crumb and the grass blades. And the grass blades were more mobile, so they were further down the stream than the rubber crumb. So what I'm saying, I suppose, is once you've got a field in an area, you're going to get loss, irrespective of the techniques or mitigation measures you put in place. Through our AusMap program, so AusMap's the Australian Microplastic Assessment Project, we sample for microplastics, all microplastics around Australia. And this is data just from synthetic grass that we have found in Sydney particularly. The map on the right and each of those points are where we found grass in our waterways. And the different coloured dots really mean whether it's low or high. So green is less than 10 blades per square metre. Everything's kind of measured as a per square metre as a standard way of reporting. You can see some high points. In Botany Bay, it was over 1,000 per square metre. That's huge, huge amounts of synthetic grass. That was right near the mouth of the Cooks River. So obviously there's something, and I'm not saying it's all coming from synthetic sports fields, because as we know, it's in people's homes, in schoolyards, playgrounds, etc. But we're finding that the grass increasing. In the northern beaches, obviously, you can see Dee Why Lagoon, Manly Lagoon, North Harbour area, all have evidence of grass. And we've got data going back. And interestingly, we're seeing an increase in this over time now, the grass blades washing up. So the blue is Manly Cove, and while there was a spike in 2022, it's been consistently high since that time period as prior to that time. It could be something to do with, we've had a lot of wet years over that time period, and we know 2019 was dry-ish, drier. So the rain definitely has a factor, we think, in this case. And Rose Bay, just on the other side, is interestingly going up each year. So they're the amounts, once again, per metre squared on average for that year. So what are some of the things that influence that loss? It's a range of factors, as you can see there. There's not just one thing. Obviously, rainfall plays a part, how much activity there is on the field, the construction, the quality of the material, definitely, the type of weave or yarn that they use, all plays a part. And then obviously the mitigation measures that field has or doesn't have is going to affect what's coming off. And then just as it ages, we know it wears more and loses more. And then there's been some nice studies, not with the whole fields, but with smaller kind of play areas that shading or cover, reducing that UV exposure makes a big difference to the life and the loss then of microplastics from that field. So range of factors that need to consider. And just my last slide is to think about going forward, what changes do we need to implement? I like what's happening in Europe. The EU has implemented some strategies for restricting at least the infill material in synthetic sports fields. That's something we can implement here, either locally or statewide. Setting microplastic targets is something also going on. Can we set to reduce how much microplastics are being released? This could be, so there's intentionally added microplastics like the rubber crumb, and then there's reducing unintentional release of microplastics, which might be more the blades. So can we use existing legislation? And Sue might talk a bit about this. So there's been a new piece of legislation that came out in New South Wales earlier in the year, the Product Life Cycle Responsibility Act is really about extended producer responsibility. So if a producer creates a product that is likely to cause harm to the environment or humans, the onus is on that producer to then reduce that harm or prevent it from happening in the first place. So I think there's some instruments, but I don't want to steal Sue's thunder going forward. So I'll leave it there, and obviously you can ask me questions a bit later. So thank you.